Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous video, we have seen an example in which we were trying to prove that a particular language is not regular. In that, we were trying to prove the thing informally. That means we don't have a mathematical base to prove that the given language was not regular. Before that, we have seen there is something called pumping lemma, which could be used to prove that certain language is not regular. Now onwards, we will be solving a few questions in which we are trying to prove that certain languages are not regular using pumping lemma. Now, before that, we have to understand how pumping lemma works on a regular language. So the first example we are going to see here is dealing with pumping lemma on a regular language. Let us see that example. So the language under consideration is the set of all strings such that the string is of the form a raised to m b raised to n, where m and n both are greater than or equal to 0. That means it is 0 or more number of a's followed by 0 or more number of b's. We have seen the strategy. In this strategy, the first thing we are supposed to do is selecting a number m. For a regular language, the m is the number of states. Now for that, let us try to draw the finite automata for this regular language. As you can see in the given automata, there are three states Q0, Q1, Q2. This automata will accept the set of all strings such that 0 or more number of A's are followed by 0 or more number of B's. For example, epsilon, maybe AB, AAB, AABB, etc. We shall apply pumping lemma on this particular language and we will prove that this language satisfies pumping lemma, but every language that satisfies pumping lemma are not regular languages. In fact, regular language is a negativity test. Just to get a feel of how pumping lemma is applied on a regular language, we will be doing this. So the first task we are supposed to do is selecting a value of m. Over here there are three states, so we will take the value of m to be 3. Here, opponent means the person who wanted to prove that the language is regular, and we are trying to prove that the language is not regular. Now, the opponent will select the number 3s for m. Now, using this number, we will have to proceed for the second step. Now, let us proceed to the second step. This step is done by a person who wanted to prove that the particular language given is not satisfying pumping lemma. The task is selecting a string in the language having length more than or equal to the given value of m. Over here in our example, the value of m is taken to be 3. So we have to select a string whose length is at least 3. Let us say the string we are selecting is 3a's followed by 4b's. Does this string belong to the language that we select? Yes, because there are number of a's followed by number of b's. This belongs to the category a to the power m, b to the power n. Now let us proceed to the third step. Now this step is performed by the opponent. So the string we are going to provide is 3a's followed by 4b's. Now what is the task of the opponent? The task of the opponent is that he has to split this particular language into three substrings x, y and z. Out of them, y is the substring which will be pumped. We shall be explaining what is pumping in the next step. Over here, the opponent's task is splitting the string into three substrings. Let us say x, y and z. Out of them, y is the portion which is to be pumped in the next step. Let us try to split the string which is given. Over here, I have shown three types of splits. Number one, a number of A's are grouped into X. The middle A and B is grouped into Y. And the rest of the portion is grouped into Z. In second one, a number of A's are grouped into X. One A is grouped into Y. And rest of B's are grouped into Z. In the third classification, all A's are grouped together into X. B is grouped in Y. Rest of the B's are grouped into Z. Now, suppose these are the three splits. Out of them, any one is given by the opponent to the person who is supposed to prove that the language is not regular. Then we will try to apply the algorithm of pumping on all these splittings, and we will find out whether is there any way in which we can pump the strings to generate the regular language. Now let us try to apply the pumping process on all these splittings. In the first one, let us do it. Let us say we are pumping it 3 times. Then what will be the string generated in the first case? You will see that this particular string is not belonging to the language that we selected. Let us see the same on second. Here we got a match. That means the string after pumping does belong to the language because it is in the form a to the power m, b to the power n, where m is greater than or equal to 0 as well as n is greater than or equal to 0. Similarly, let us try to pump in the third string. Here also you can see that the string is still in the form a to the power m, b to the power n. Hence, after pumping, we got at least 2 combinations in which the language of regularity is still holding. Hence, we cannot prove that this language is not regular using pumping lemma. In fact, this language is regular itself. But passing pumping lemma does not mean that the language is regular. This is just to get a feel of how pumping lemma works on regular languages. Now we will apply pumping lemma on non-regular languages and prove them to be non-regular. As you can see, we have 2 cases which are passing pumping lemma, hence we cannot prove that this language is irregular. In fact, this language is regular. From the next video, we will try to solve the same using non-regular languages. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.